One of the most important mathematical processes you can take from this class is unit conversions, going through what are called dosage calculations. You'll need this in pharmacology math, and really you use this a lot, but it's algebra based for the most part, switching from one unit to the next. It is a skill set you're going to use throughout this semester and into your nursing career. What you need to find when you are starting out a unit conversion is the measurement that was recorded. The measurement, as we have discussed before, requires a number and a unit because we need to know where we're starting from. Then you need to determine what are called the conversion factors or connection factors. It is what connects the different units together. When you're in metric prefixes, going from kilo to your base unit to milli, that just requires going or moving your decimal because you're just changing the prefix, not the base unit. But when you're switching the base unit, we have to have a way in which we connect different base units together. And those are the conversion factors or your connection factors. An example is, let's say we have 12 eggs. We know that another unit for 12 eggs is a dozen. Or sorry, 12 is a dozen. Therefore, we have our units, eggs, and dozen. And we've got the number before. Because these are a set ratio, they can be used as a conversion factor. These are set. 12 equals a dozen. 12 eggs, 1 dozen. So the conversion factor or connection factor we can go through and allow us to convert between eggs and a dozen. To set this up mathematically, we tend to use what are called T-charts. Or you can look at it kind of like setting up fractions. So what we do is we're going to have our measured number to start with. So then we have our T-chart. I've also heard these called fence posts, or you can set them up as like fractions. So when you have your measured number, here then you're going to put your conversion factor. That allows you to cancel out the unit that is in the measured number and convert to the unit that we are looking for. And it's going to be a different base unit. And then that's going to give us a number based off what we're provided with the desired unit that we are looking for. Looking at the significant figure rules for conversion factors, we already know that our measured number, the number we're going to start our calculation with, is an inexact number, therefore participates with our significant figure rules within our calculations. Conversion factors may or may not be significant, and so we need to know the difference between them. Exact or established numbers, those that do not count towards sig figs, these conversion factors are set. They are agreed upon within the scientific community. English to English, like going 1 foot equals 12 inches. We all agree on that. That is a set factor. Metric to metric, changing of the prefix. So we know 1 kilometer is equal to 1,000 meters. We know that. That is set. We even have English to metric set. Even though it is technically measured at some point, it is consistent across the scientific community. We all agree that 1 inch equals 2.54 centimeters. we are going to assume all of these English to metric conversion factors are exact numbers. Inexact or measured conversion factors do count towards your sig figs. As we talked about, that's going to be the starting value, or measured conversion factors. These are conversion factors that are unique to the situation, especially for dosage calculations. We're going to have 5 milliliters per 10 kilograms. That's going to change depending on the medicine in which you're going to dose. Therefore, this would be a measured conversion factor. What we're typically looking for is this per. That per tells us we've measured something. When we have our established conversion factors, we tend to put those in the parentheses at the end of the word problem. Here's the process for approaching a word problem. This is also provided to you in your guided practice, and it is the steps that we're going to use all semester, so hopefully they become second nature. It is important for you to be consistent in how you set up your problems. Don't try new techniques on a quiz or exam because they typically will cause your anxiety to rise. How you practice your setup and completion of these problems is how you want to assess or use that process within your assessments. This process is one that I've honed over time based off students' feedback and what has worked. If you find something different, please let me know and I will include that in my future instruction. Approaching a word problem. Read the entire problem first so you know what you're doing. How many inches are in 2.00 miles? Underline known information. What are the values given to me? How many inches are in 2.00 miles? I have my measured value, number, unit. I was also given some information after. Parentheses, that is a conversion factor. It is a set conversion factor or an exact. Box, what it is you're solving. How many inches? We are looking for a unit that is not associated with a number. Ideally at this point, because you're going to be testing online, you're not going to be able to be writing on the paper like I am writing right now. Therefore, I suggest writing this information down on your piece of paper or scratch paper so that you don't have to keep looking up and referencing online. So I'm going to pull this information down. I'm reading it on my screen. I'm going to write it down on my paper. I know that we're starting with 2.00 miles. I was given a conversion factor. At this point, I suggest writing the conversion factor both ways until you become comfortable and confident in how to identify how to put the conversion factor together. And I am looking for inches. All right, write a unit map. This is probably one of the most important processes in this entire step because it's going to align the units so that they cancel out and you are transitioning appropriately. And then we're going to go put back the numbers. Students tend to just kind of jump forward and having to put numbers and units together, a lot of mistakes can happen. If you put the units in first, the numbers will follow. What this unit map looks like. I put the unit I'm going to start with first. So I was given miles. I ultimately want to get to inches. So my first conversion, I've got to get to a different unit out of miles. I was given a conversion factor with miles in there. So I can go to feet first. And I have a conversion factor that allows me to do that. So I'm going to put that conversion factor down here so it is set up for me already. Now feet are not inches, but I know how to get to inches from feet. So from feet, I can get to inches. I know there are 12 inches in 1 foot. Inches is what I'm looking for. So now I'm ready to set up the calculation. So I have my units in. Now I'm going to put in what it is I'm starting with, 2.00 miles. I'm going to connect everything. First thing I'm going to do is make sure my units cancel. Units follow similar processes to numbers. If units divide from each other, they're canceling each other out. If units are multiplying, then they get multiplied together. That's where we get meters squared, or grams times degrees Celsius. So here, we're only looking for one unit at the end. Therefore, any other unit we've used in this calculation must cancel out, and the only way they can cancel out is by dividing. So let's check our work. We have miles on top and on bottom. They cancel out. Feet on top, feet on bottom. They cancel out. The only unit I have left is inches. That is what I'm looking for. Therefore, I have set up my units correctly. Now I'm going to go through and complete my calculations. With these in our calculations, let's use horizontal line means to divide, just like you'd set up traditional division problems. The vertical lines are to multiply. So essentially what we are saying is we want to multiply 2.00 times 5,280 times 12 divided by 1 times 1. All right? How you want to do this in your calculator is up to you. You could multiply all the way across the top, bottom, and then take those two numbers and divide. If you're going to plug it in all at once, make sure you have like big parentheses surrounding everything so you don't have PEMDAS screwing up your calculation in the end. All right, so when you do this and you're going to enter this into your calculator, you are going to get 1,26720. Significant figures matter because that gives us the precision of the instrument in which we measured. We go back and we look at that problem. We are only given one measured value in the problem because our conversion factors are exact or established values. Therefore, the number in the problem gives us our number of significant digits. There are 3 significant digits there. Based off multiplication and division rules, we want to go to the least number of sig figs. So it needs to match 3. 1, 2, 3, draw my line. Does my discarded 7 cause 6 to round up? Yes, it does. Now, this 1 has to stay in the 100,000th place, which means the discarded values are zeros. They're insignificant. There is no decimal value. We have 127,000 inches. If you want to go to scientific notation, remember our mantissa is going to be the 127. Then we're going to count 1, 2, 3, 4, 5 times 10 to the 5th. It is never wrong to go to scientific notation because it does show you what is considered significant. It is up to you on how you want this final problem to be represented. Went through all the processes. I have a number, I have a unit, and the correct number of sig figs. And that's how you complete a unit conversion. I'm going to do another example. If you're good, you can stop the video here. If you don't watch me work through the example, feel free. All right, so step 1 of the process, read the entire problem. How many seconds are in 0.35 hours? Step 2, underline what was given to us. What do we know? We know 0.35 hours. That's the only thing given to us. What box, what we are looking for? So we're looking for a unit that is in question. How many seconds are there in 0.35 hours? Next up, write everything down. So I know I have 0.35 hours, and I am looking for that value in seconds. That's all that's given to me in the problem. Most important step, unit map. So here, we want to get from hours to seconds. If I have hours. How do I want to get to seconds? Well, we can go directly from hours to seconds if you know that conversion factor. But I'm going to do this in multiple steps. I know how to get to from hours to minutes because I know that there are 60 minutes in 1 hour. I know how to get from minutes to seconds because there are 60 seconds in 1 minute. So that gets me to the unit I am looking for. That is my unit map. Now I'm going to bring down the number and unit that I started with. Next step. Do I cancel out all the units I need to and end up with the unit I am looking for? Hours, top, bottom, cancel out. Minutes, top, bottom, cancel out. And I am left with seconds. And that is what I'm looking for. So I set the problem up correctly. Now I'm going to work this through mathematically. So 0.35 times 60 times 60. Divide that by 1. I'm going to plug that into my calculator, and I get 1260. Now I need to go to significant figures. I have whatever measurement I have for hours. Going up back to my problem, I only have one measured number. Therefore, the sig figs are going to come from that measured number. There are 2 significant digits in this value because that 0 is leading and just gets us to the 3. Therefore, our final answer needs to have 2 significant digits. 1, 2. Does my discarded 6 cause my 2 to round up? Yes, it does. So I have 1, 3, 0, 0, because that 1 still needs to be in the thousands place. That 3 needs to be in the hundreds place. And we have our unit. Oops, just a second. So 1,300 or 1,300 seconds. In scientific notation, that's going to be 1.3 as my mantissa times 1, 2, 3 second. So either way works.